Welcome to SGITMystr, your ultimate destination for futuristic technology and AI innovation.
Welcome back to our Kubernetes series. Today we're diving deep into real-world troubleshooting, focusing on 5 of the most common deployment disasters you'll face. Leveraging the momentum from our deep dive, this video is all about high-value problem-solving skills requested directly by our community. Let's get started on mastering K8's troubleshooting. The reality of Kubernetes deployments is that failures happen. Even with perfectly defined YAML, misconfigurations, resource constraints, or simple typos can cause major headaches. We'll show you how to navigate these common failures. We've identified 5 major deployment disasters that consistently trip up developers and engineers. Here's a quick overview of what we're tackling today. ImagePullBackOff, CrashLoopBackOff, OOM killed, pending pods, and service not reachable. Our first disaster is ImagePullBackOff. This is typically the easiest to diagnose, as it means Kubernetes couldn't pull the container image defined in your deployment. The root causes are simple: a typo in the image name or tag, using an image from a private registry without providing authentication credentials, or having an issue with your image pull secrets. The fix involves 2 steps. First, verify and correct the image name and tag in your deployment YAML. Second, if using a private registry, ensure your image pull secrets are correctly configured and referenced. Next up is CrashLoopBackOff. This is when your container starts, immediately crashes, and Kubernetes attempts to restart it repeatedly in a loop, often indicating an application-level error. Common root causes include application errors that lead to immediate exit, a misconfiguration in the environment variables, or a failed liveness or readiness probe that Kubernetes interprets as unhealthy. The most crucial step here is checking your application logs using kubectl logs. Look for startup errors. Also, review your liveness and readiness probes in the deployment specification for incorrect paths or settings. OOM killed, or out of memory killed, means your container exceeded its allocated memory limit and was terminated by the kernel. This is a clear resource constraint issue. The primary cause is setting memory limits too low for your application's actual needs, or having a memory leak in the application itself that causes gradual consumption. To resolve OOM killed, you must adjust the limits and requests for memory and CPU within your deployment YAML. Increase the memory limit to accommodate the application's peak usage. When pods stay in a pending state, it means the Kubernetes scheduler cannod find a suitable node to run them. The system doesn't have the necessary resources or permissions available. Root causes include a lack of available CPU or memory across the cluster, or the presence of node taints that prevent the pod from being scheduled unless specific tolerations are defined. The primary fix is to scale up your cluster by adding more nodes. If taints are the issue, update the pod specification with appropriate tolerations, or remove unnecessary taints from the nodes. Our final disaster. The service is deployed, the pods are running, but you can't reach the application from outside or even inside the cluster. This is often a networking configuration problem. Root causes include incorrect port mapping between the service and the pod, missing or mismatched selector labels between the service and the deployment, or external firewall rules blocking traffic. Verify that the service selector exactly matches the labels on your deployment's pods. Also, ensure the service's target port maps correctly to the container port defined in your deployment. Mastering reactive fixes is great, but becoming proactive is the key to minimizing deployment disasters. Always review your configuration before applying. Remember these vital debugging commands: kubectl describe for object details, kubectl logs for application output, and kubectl exec to run commands inside a running container. Thank you for tuning in. For ongoing learning and to dive deeper into these topics, check out the community resources linked below. Don't forget to like and subscribe for more Kubernetes content.